These 10 questions are rated hard in the College Board question bank, but if you know how to approach them, they're really not all that challenging. Just remember to get the most out of this study video, you're going to want to pause and attempt each question on your own first. Let's get started. All right, in the xy plane, a line with equation 2y equals 4.5 intersects a parabola at exactly 1 point. Let's stop there. What does this mean for an equation to intersect a parabola at exactly 1 point? So let's think about a parabola. Basically, we have a couple of options. Most of the time, we either have a smiley face parabola, something like this, pretend it's beautiful, or we could have a frowny face parabola. Technically, we could also have a sideways parabola, but these are the standards, right? So what are the possibilities for a line intersecting these at 1 point? Well, let's think about it. And going back, it did say 2y equals 4.5. So if just saying y equals something, which means it's a perfectly straight horizontal line like this, that goes through 2 points, right? That goes through 0 points. The only way it's going to hit 1 point is if it goes exactly through the vertex. So this is going to be the only way that we get a line hitting only 1 point on a parabola. So anytime you see exactly 1 point, just remember we're thinking about the vertex of the parabola. All right, 1 point vertex. If the parabola has equation where b is a positive constant, what is the value of b? Okay, so we know that we're looking for b, and we know that we're looking at an intersection at the vertex. So let's go to Desmos and plug these in. All right, so I've plugged them both in, and if you're not familiar with Desmos, it's saying add slider b. So because we're using a constant here, anytime you use a letter other than x or y, it's going to ask you to add a slider, and a slider is basically going to let us choose a value for b. So here's the fun part. We can slide this around, and you're going to see that it affects our parabola, and we know that we want it to touch at only 1 point. So we want an intersection at the vertex like this, right? So here we have an option where it's working. B equals 6, okay? But it looked like there was also another option right here where it was working. B equals -6. So then how do we know what our answer is? Is it 6 or -6? There we go. B is a positive constant. So what is the value of B? It is 6. So just remember, whenever you are working with constants, if you are trying to determine that constant, you can pull up one of these sliders and then just slide around until you find what you're looking for. The circle above has center O. The length of arc ADC is 5 pi. Let's label that real quick. Definitely always going to recommend that you label your geometry or draw your geometry if they don't give you a picture. So ADC, that's going to be the small arc, right? So that's 5 pi right there. And x equals 100. So this guy right here is going to be 100 degrees. All right. So what's the length of ABC, which is the rest of the circle basically, right? So how the heck are we supposed to do this? Well, what do we know to be true about every circle in the known universe? That's correct. They all have 360 degrees. So it would be safe to say that this little fraction of the circle, this sector of the circle, is going to be 100 degrees out of 360 degrees, right? And here's something that's cool. Any central angle is going to make up the same proportion as the arc that it subtends. That is to say, if this is 100 out of 360 degrees, whatever that proportion is the same amount that 5 pi is compared to the rest of the circumference. Because an arc is basically a piece of the circumference, right? So what we can say is that this is equal to 5 pi out of the entire circumference. What are we going to do with this information? Well, we could certainly solve for circumference, and we could do that simply by cross multiplying here. And we do see pi in all the answers. So for that reason, I'm going to ignore the pi. All right. I don't want you to freak out. I'm ignoring the pi because pi is in all the answers. I'm also going to get rid of these zeros just to make things simple, which I'm totally allowed to do. Totally optional, but that's my preference. So first I'm cross multiplying 36 times 5. And just FYI, this is something that you can do whenever you have fractions equal to each other. You can cross multiply, aka you multiply the diagonals. You could totally do this on your calculator, but 36 times 10 would be 360, so half of that would be 180. And then 10 times circumference equals 10 circumference. So basically, if we divide by 10, our circumference is going to be 18. Technically 18 pi, but we got rid of the pi, right? Okay, so this is our entire circumference. 18 is our circumference. And if we go to the answer choices, sure enough, 18 pi is one of the answers. But we got to be careful. This is a difficult problem, not only because you need to understand the concept behind how arcs and sectors work, but they also have a trick answer here. Because if we remember from the question, and I probably should have underlined this, always double check the main question. What is the length of arc ABC? We're not looking for the circumference, so C is not our answer. Our answer is going to be the circumference minus 5 pi, right? Because we want just the rest of the circle. So if we take our circumference 18 pi and we subtract the 5 pi, we're left with 13 pi, right? Or just, 13, because they all have pi in the answer. So our answer is actually going to be B. All right, here we've got equivalent expressions, and we also have constants involved, which for some students is really intimidating. And, just looking at this, it doesn't look like it's going to be a lot of fun. We're thinking maybe we have to FOIL everything out and then who knows what, right? So there is a way that we can deal with this using Desmos, but I think it's still going to be a pretty long and drawn out process. So I'm going to show you what I think is the best possible way to solve this type of problem, which is using matching. And what we're going to want to match is AB, and then whatever AB is affiliated with. Let me show you what I mean. I need to get AB to exist first. So looking at the left side, rather than FOIL out this whole thing, let's only FOIL out the part of it that would create AB. So when we multiply AX by negative BX, we're going to get negative ABX squared, right? So that's what I mean by extracting AB. We find where AB comes from on the left side. So that's where AB is going to come from. Now, I need to also extract anything else from the left side that will be times x squared. Because basically values that are acting as coefficients for the same degree are going to be equal to each other. Let me just show you a quick example. So if we had let's take this, and then this was equal to ax to the third minus bx squared minus 2x plus 12. We would know that a equals 20 because these guys are both being multiplied by x to the third, and b equals negative 9 because these guys are both being multiplied by x squared. That's always going to be true of equations. Those coefficients being multiplied by the same degree, whether it be x squared, x to the third, or nothing, right? We could also say instead of plus 12, we could have plus c. And we know that c equals 12 because it's not being multiplied by x at all. So those will always be equal to each other. Anyway, going back to the problem at hand, we need to find out what else from the left side is being multiplied by x squared. Again, we don't have to extract this whole thing. We don't have to FOIL it all out. We just have to figure out where would x squared come into place. X times x makes x squared. And then, of course, 5x squared times 3 would still result in an x squared, right? It would be 15x squared. So that's literally all we have to do for the left side. And on the right side, all we're going to do is pull out things that are being multiplied by x squared, aka negative 9x squared. So we're following here. We just have all of the x squareds basically. Why the x squareds? Because we want to know the value of AB, and that's what AB is being multiplied by. Okay, and from here we just solve. We're going to subtract 15x squared from both sides. Negative 9 minus 15, what is that? Negative 24. And then here things get really easy. We have two negative signs, so we can get rid of those and turn them into positive, because we're basically just multiplying everything by -1. We have x squareds that can be eliminated, because if we divide the whole thing by x squared, they disappear. And then AB equals 24, just like that. All right, we've got a bit of a word problem here. And with word problems, I'm going to recommend that you skip all the way to the main question so that we don't end up reading things that we don't need to read. So the main question, which of the following systems of inequalities represents the conditions described? Basically, which one of these equations is true based on the scenario that they're giving us? So instead of reading this whole thing, let's try to find some differences between our answers and then just check to see what's true. One of the first things that I'm noticing is our answers will either be less than or equal to 10 or greater than or equal to 10. So for less than or equal to, we're looking for some sort of language like no more than, right? And then for greater than or equal to 10, we would want at least, because greater than could be the least or it could be more than the least. So here it says Marissa needs to hire at least 10. So we know that it's going to be greater than or equal to. Here, again, let me just write that down for you. Good one to remember. At least is going to equal greater than or equal to. So for that reason, we can eliminate A, because it has the wrong one, and also D, because it has the wrong one. Okay, let's do the same thing. Let's look at B and C. What are the differences? Well, going on down the line, these are both the same, so we don't want to look at that, but we can see that both X and Y are either going to be greater than or equal to, so we're looking for maybe at least, or again, if they're less than or equal to, we're looking for something like no more than, right? And I guess I could write that down too. And it does say that X is junior directors and Y is senior directors. So basically, we want to look for that language. Oh, and I do see it here. So at least 3 junior and at least 1 senior. So at least is again going to be this one, which is shown in answer choice B. So our answer has to be B. So this next one has a really cool trick. All you need to do is boop the like button. Boop. Okay, but for real, let's take a look at this one. So we have a table here, and you can certainly plug tables into Desmos, but right off the bat, I don't like the way this is looking because we have a constant here in the table, and then there's another constant here in one of these points. And I'm having a feeling that Desmos might not be that helpful for this one. So let's just try and figure out what's going on here. It says the y-intercept is going to be k minus 5, comma b. So basically there's a line that is represented by this table, and the y-intercept is going to be this crazy point that has 2 constants in it. How are we supposed to deal with this? Well, the fact that it's a y-intercept is super helpful, because if we think about it, any y-intercept is going to be the place where a line crosses the y-axis, right? So here, the y-intercept is right here. If we look at another line, the y-intercept is right here. We could even do a third line, or boom, all right? There's the y-intercept right there. What do they all have in common? Because they cross the y-axis, the value of x is 0, right? This is at 0 for x. So we were actually given a hint here that this should be 0, so k minus 5 equals 0. And if k minus 5 equals 0, we can add 5 to both sides, and now we know k equals 5. All right, this is starting to look a little bit better. So we can change this. Instead of k13, it'll be 513. Instead of k plus 7, negative 15, it'll be 5 plus 7, which is 12. And now I'm feeling a lot better about this. From here, we can do a couple different things. If you want, you could use the slope formula to find the slope of this, because our basic formula for a line in slope-intercept form would be y equals mx plus b. We could use the slope formula to find m, and then we could plug in one of these points, solve for b that way. Or we could use Desmos and just plug it in. Let me show you both ways, just in case one of them is faster for you. So let's start with the way I said, where we're gonna just find our slope and then plug it into that formula. If you're okay with it, I'm gonna get rid of this stuff. And to find our slope, we wanna do difference in y divided by difference in x. So often it's written as y2 minus y1 divided by x2 minus x1. And plugging in those y's, we would just take these two y's here. I'm going to start with the positive one. So 13 minus negative 15 is the same as plus 15 divided by, now I started with 13, so I need to make sure that I start with the 5 there, the corresponding x. 5 minus 12. 13 plus 15 is 28, I believe. And then 5 minus 12 is negative 7. 28 divided by 7 is 4, so negative 4 is our slope. So now we rewrite y equals mx plus b. We can change m to negative 4, so our formula is y equals negative 4x plus b. And then we just plug in one of these points. I'm going to go with 513 because it doesn't have a negative number, and that seems a little bit easier. So instead of y, we'll have 13. Instead of x, we'll have 5. And then we're going to solve for b. So negative 4 times 5 is negative 20. Add 20 to both sides. 13 plus 20 is 33. And that would mean that 33 equals b. So that's one way to do it. Alternatively, we can go to Desmos and we can just plug in a table. All you need to do is click on the plus sign up here, add table, and then we plug in our values. So we had 5, 13, 12, and negative 15. Whoops, negative 15. And right now, I see there's just a little point here. One thing you have to remember with tables is you need to adjust this. Click on the little gear sign, click on the dot here. You can change the color, which is, not super helpful, but what we can also do is click on lines, and boom, now we have a line. The problem is this is not going to the y-intercept. So let's add our y-intercept, x equals 0. And then what would y equal? Well, we know it's going to be somewhere up here, so we could say like 20. But now you see we have two different lines. But if we keep messing with it, if we say like 25, 30, 32, 33, boom, it lines up. So that's a way that you could do it with Desmos. You could also take this value and call it like a, right? And then just say a equals 1. And now we can slide a around until it gets to where we want it, basically so that this is a single line and they have the same slope, right? So that's another way to do it and get 33. For this type of question, I would honestly recommend the first method that I used. It's important for you to get used to the basics of y equals mx plus b, finding slope, things of that nature, because it's such an essential part of algebra, and it's going to serve you on the rest of the SAT as well. All right, so we've got a linear function here, and basically we're trying to choose the equation that lines up with whatever scenario is going on. So let's figure out what's happening here. A window repair specialist charges $220 for the first 2 hours of repair, plus an hourly fee for each additional hour. So we could think of this as kind of like a one-time fee of $220. So it would be like y equals mx plus $220. As long as we remember that x is going to equal the third hour, right? Third hour. Because those first 2 hours are the $220, and then after that, it's going to be the third hour and beyond. So that's one way that we can think about it. And then it says that the total cost for 5 hours for repair is $400. Let's go ahead and figure out what our equation would look like in that case. So the total would be 500, and that's going to equal, basically third hour and beyond. So 5 hours would be M3, because we're getting rid of those. And M3 is kind of weird, so I'm just going to say 3M if that's okay with you. 3M plus 220. We could subtract the 220. 500 minus 220 is 280. 280 divided by 3. That is not going to be a clean number. And why is that? Because it's not supposed to be 500. It's supposed to be 400. My bad. Okay, 400. So instead of 280, it should be 180. And of course, that's going to be a nice clean number of 60. So m equals 60. And then our equation becomes y equals 60x plus 220. But we got to be careful because remember, we said that our equation was based on the third hour and beyond, but it's saying just the cost for hours, and it's asking for when x is already greater than or equal to 2. So we need to get rid of those first 2 hours from our total. And if each hour is 60, then 2 hours would be 120. So if we subtract 120, we get y equals 60x plus 100, which is actually our answer. Again, we had to make that adjustment because my original thought was we're only talking about the third hour and beyond being x, but here it's saying straight up the number of hours. Okay, so that's one way that we could go about this. However, I think we could also use Desmos. Let's see what happens if we plug some answers into Desmos. And we'll start with A. Just remember that f of x is basically y, so that's going to turn into y. So first answer was y equals 60x plus 100. Okay, so we have a line. How is the line going to help us? Well, we can double check to see if the point matches up because they basically gave us a point. They said 5 hours of repair, so 5 equals x is $400. So we're looking, does the point 5, 400 exist on the line? If this point exists on the line, it should be our answer. So we're going to scroll out, and this is why you always want to have your calculator handy. All right, there's 400. And if we go to 400, look at that, 5, 400. So we know that A is our answer. So there's a much faster way of going about it. Now, we did get lucky because the answer happened to be A, but we could go through pretty quickly and eliminate these other ones as well. All right, we got a little bit of a word problem here. So let's start with the main question, aka the last question. How many seconds after the launch does the model estimate that the projectile will return to a height of 7 meters? Okay, so we're looking at time as our answer. So we have to think about time as being either an x value or a y value. Well, it says that there is a projectile. So there's a projectile being launched. It's telling us it's a quadratic function. So let's just kind of get in our heads what's going on here. If we thought about this on a graph, a quadratic is going to be a parabola, right? And anytime a projectile is being launched, it goes up into the air, and then it comes back down. So this is kind of what we're looking at. It also says it starts with an initial height of 7. So we could, say that our y-intercept here is 7. It's going up into the air. And we're trying to figure out not what the x-intercept is, but rather when does it get back to that height of, 7, right? Okay, so in a nutshell, that's what we're dealing with. So we need to start with some sort of equation. And for a parabola, we have 3 different options. We've got standard form, we've got factored form, and we've got vertex form. Here, they're telling us the maximum height, which would be the vertex, right? Because it's never going to go higher than this. They're also telling us when the maximum height happened. It happened 3 seconds after launch. So we know that our vertex is going to be 3, 51.1. So for that reason, I would say let's use vertex form. Vertex form is going to be y equals a x minus h squared plus k, where h is the x coordinate of the vertex and k is the y coordinate. So if we plug those in, y equals a times x minus 3 squared plus 51.1. So we already almost have a full equation here. The only thing that we're missing right now is our a value. So if we could somehow figure that out, we would be in really good shape. Is there a way that we could do that? Well, if we had a point to plug in for x and y, then we could solve for a. Do we have a point? Well, we kind of do. They told us that the initial height was 7, right? We know that the y-intercept is 7. And at the y-intercept, y would be 7, and x would be 0. So let's figure out what a is real quick. Negative 3 squared is 9. So this changes to 9a plus 51.1. Subtract 51.1, and I'm going to use my calculator for this. It'll be negative 44.1. I'm going to make some room for myself here. Divide that by 9. So a equals negative 4.9. All right, we're almost done. Let's just go over here and update our equation, because remember, initially it was y equals a times x minus 3 squared plus 51, but now we know that a is negative 4.9, so we're just going to plug that in, and definitely pause and go back if you need to. Replace a with negative 4.9. And then our final question here is how many seconds would be x for it to return to a height of 7 meters? So basically, when y equals 7, what is x? So we plug in 7 for y. 7 equals negative 4.9 x minus 3 squared plus 51.1. And to make things easy on ourselves, let's go ahead and plug this into Desmos. So all we have to do is plug in our equation, and I'm talking about our original equation without y plugged in. And then we're going to scroll out, and we're looking for y equals 7, right? So there's 7, and look at that, x equals 6. So our answer is 6. All right, so here we have a question about mean, and we want to probably start with the formula for mean, which is sum divided by total. The sum is the sum of all values, and the total is the total number of values. So what would this look like if we plugged it in with the information we have? Well, they said the mean score of 8 players, so 8 players is the total number of players, so that would be our total. The mean was 14.5, so that's going to replace the word mean. And the sum is our only unknown. And we might as well figure out what that is. Could come in handy, right? So if we multiply 14.5 times 8, let me use my calculator so I don't get myself into trouble here. 116, and that's pretty much everything there is to know about the first sentence. Moving on to the next sentence, if the highest individual score is removed, the mean score of the remaining 7 players becomes 12 points. Well, let's just write our equation again. The new equation has a total of 7 instead of a total of 8. The sum is still unknown, and the new average was, because mean is average, the new mean or average was 12. So we'll change this to 12. And then this one I think I could do in my head. 12 times 7, well, basically 7 times 10 would be 70. Add 14 to that, we get 84. And then it says that the highest individual score was removed in order to get down to this number. So basically, what's 116 minus 84? 116 minus 84. I don't feel like doing that in my head. I'm just going to plug it in my calculator real quick. And that's going to be 32. So our answer should be 32. Okay. So this next question is what I would call a nightmare. This is absolutely terrifying looking. I hate it. There's fractions, there's a constant. So let's try and figure out what's going on here. Main question says, if the system has no solution, what's the value of p? So let's start with that. No solution. What does no solution mean? No solution in the case of 2 lines means that they're never going to touch. So if we visualize this, let's say we got a line here and we got a line here. They're touching, right? So that would not work. We could have something like this where they're not touching, but if we keep going, eventually they're going to cross paths, right? So the only way to have no solution is if they never ever touch, aka they are parallel and have the same exact slope, all right? So always remember, no solutions for 2 linear equations. You want to think same slope. How does that help us here? Well, basically, we just have to figure out what value of p would give the bottom equation the same slope as the top equation. And that could still be a nightmare because, I mean, what I'm thinking is we put the top equation into y equals mx plus b, so we know the slope, and then we mess with the bottom equation to kind of figure out which value of p gives us that same slope, which is not fun. But you know what is fun? Doing a little cheat with Desmos since we're allowed to use Desmos. So let's pull up Desmos and just plug these in. All right, so my first one was 3 over 2y minus 1 over 4x equals 2 over 3 minus 3 over 2y. Okay, there's one line. It does take a while to type in, but I promise you it's faster than doing it on paper. Okay, and then we have 1/2 x plus 3 over 2 equals py plus 9 over 2. And since we have a constant p that we're trying to figure out, we do have to add a slider. So add a slider. And now, remember what our goal is? We're trying to get the same slope. We're trying to make these guys parallel. So we basically want to play with this until they are parallel. So if we slide this around, we can see that when p equals 6, they are indeed parallel. So our answer is going to be 6. All right, we've got a geometry question here, specifically dealing with lines and angles within triangles, and we're trying to figure out what this unknown angle is over here. So the only information we're given is that RT and TU are congruent. So I'm going to signify that with a couple of little lines. Let me make these real small, because you know what? I'm going to zoom in because I need to see exactly what's going on here and to show you exactly what's going on here. All right, and TU are congruent. Why is that important? Well, if they are congruent, that means we have an isosceles triangle and our angles are also going to be congruent. So I'm just going to signify here that these guys will also be congruent. So right off the bat, we can figure out what these angles are because every triangle has 180 degrees. So then basically, if we subtract our 114, we're going to be left with the remaining degrees available for this triangle. And then if we cut those in half, we'll get the angle of R and U, right? So basically we could say like 180 minus 114 equals, 2x, or I shouldn't say x because x is what we're looking for. We'll say 2y. And that is 66 equals 2y. So then y equals 33. Okay, so that was just to figure out, that this is 33, which I don't really care about, but more importantly, that R over here is 33. Okay, so I think that's one step closer. Now, if we can just figure out what this top angle is, then by process of elimination, we could subtract and figure out what our final angle is. Let's just play ring around the rosy here. What can we see? Well, if this is 114, then this angle, because it shares a line with it, is going to be 180 minus 114. Because these are, I can't remember the term for it, but basically if two angles share a straight line, they add up to 180. It's either supplementary or complementary angles. I can never remember those two. But yeah, that's the rule. Straight line is 180 degrees because it's half a circle, right? This would be a circle, 360. If we cut that circle in half, then it would only be 180. And we actually already calculated that, right? We did 180 minus 114 just a second ago, and that was 66. So we know that this is 66. Now we can figure out this angle down here, right? Because we know 180 minus 31 minus 66 is going to be whatever's left over is that angle, and that's going to be 83. And then these ones, I do remember the name of. Anytime you have this sort of hourglass thing going on, basically the angles that touch tips are called vertical angles, and vertical angles are congruent. So this will also be 83. So then the last ring around the rosy that we need to do is 180 minus 33 minus 83 equals x. Plug that into my calculator because I'm lazy like that. And that is going to be 61. So x equals 61. What? Come on, bro. Okay, I accidentally put in 86 instead of 83, and that equals 64. So x equals 64. Let's zoom out and hope that that's actually one of our answers. It is. Okay, yeah, so 64 is our answer there. Ta-da! Getting more comfortable with these types of questions is definitely going to improve your score, not just because you know how to solve more problems, but also it'll improve your pacing. But if you're still having trouble running out of time in the math section, check out this video right here.